always forget. Oh, I always forget. So anyway, if you want, you can write it this way. You can write E. It's going to be the expectation of X, where X is going to be greater than var. Because this is just looking at the upside, right? It's going to look at the upside, right? It looks at this side. You can only do this when there is symmetry, right? This is because we are trying to avoid the negative side, right? In such a case, you can just write 1 over minus alpha, and then you will have what? This is what you will have. You will have from negative infinity. No, not from negative infinity, but from var alpha to infinity x f of x dx. So either way, you find the answer. Yeah. Either way, you should find the answer. So I can't find questions for expected shortfall in the exam, but neither in the semester test. I don't think it was in the semester test. If there's anyone who have the question which is based on the semester or exam, and send me. But anyway, I am going to move to expected shortfall, which we already learned about later on. I mean, earlier, before we came to VAR, because I wanted to talk about it anyway. So this one, they do examine it. Actually, they both examine both of them, but then I'm not sure. I haven't seen a question based on expected tail loss. So again, expected shortfall is going to be equals to, always remember that it's going to be L minus X, right? So it's going to be the expectation of the maximum value of X, of the maximum L minus X or 0. This is how they define it in your book. But you can basically write it this way. You can just write it this way. You can just say it's going to be equals to, for this group, it's going to be from negative infinity to L, given L minus X, f of X. It's f of X dx. Or for discrete, you will have the sum of where X is going to be less than L, where you have L minus X, the probability capital X equals to X. So this is how you define your expected shortfall, right? So yes, I have question papers from 2010 to 2014 and 2019 to 2020. So I can't find a question on expected tail loss, but then I did find a question on shortfall, which we did already. So I am going to skip for this one, if that's fine with everyone. Or if you have any question, please send it to the group and then I can do it on the session. I'm like, yeah. But anyway, I have to go to other question because we have to maximize our time to answer questions. So which brings us to the last session, which I promised, right? So most of you want to know about Markowitz model. Some of you. The people that asked for Markowitz model, I don't think that they are even attending. So if, okay, by popular mind, how many of you actually want Markowitz model? And then how many of you want stochastic dominance? Or should I try to do both? But I don't think we will have the time. Okay. Okay, I will do Markowitz model. So the reason why it might be a little bit difficult is because Markowitz model, you did it at the beginning of the semester and your memory is crusty. And then another thing is that you did it again at the beginning of the semester. So when you were not very familiar with the subject. So this is why it's a little bit difficult for most of you. So Markowitz model is actually about minimizing your risk, right? So you are trying to minimize variance, right? They say minimize variance, and they define variance as 1/2. The sum of I, J, weight I, weight J, sigma I, J. Okay, I see a question. I see someone sending a question in the group. This is for var. Oh, okay. There's conditional var as well. Okay, so this is how you define variance. So anyway, you're gonna have two constraints, right? You will have two constraints. The first constraint is gonna be what is gonna be the weight, right? So the weight needs to be actually equals to 1, right? So this is your first constraint, and then your other constraint is that the returns times the weight should actually be equals to the portfolio return, right? So this is what you are trying to solve. So I'm not gonna prove this formula because I think by now most of you can, but then at the end it will lead to something like this. It will lead to sigma 1 1 all the way to sigma 1 2. I mean sigma 1 n minus r1 minus 1 sigma n1 all the way to sigma nn negative sigma return of 1 return of like 1 returns of 1 all the way to the expected returns of n 0 0 1 1 0 0. And then you will have your weight 1 all the way to weight n. Then you're going to have your lambda and your mu equals to 0 all the way to 0. Your returns for portfolio and 1. So you are actually trying to solve this thing. Né? So so yes, this is what you are trying to do, right? You are trying to solve so if you have a, if this matrix is a and then this one is x equals to b, né? So you are trying to solve for x. So you are trying to find what are the weight of each asset as well as the lambda and mu, and then you can solve for it, right? So if they do ask you, so a question like this, they can ask you to do it in Excel. So fine. But then if they do ask you to solve it, they would actually make the matrix much easier because it takes time to actually solve this thing. So you can reduce your rows, or you can even use Cramer's rule or any method you have in mind to simplify this equation. So so yes, there is another thing. There's another method you can use, right? Instead of using this long matrix, right? Sometimes they cannot give you the returns, right? Sometimes if they don't specify the returns, the portfolio returns, right? If they don't specify them, and then they ask you to find minimum variance portfolio. minimum variance portfolio, MVP. They normally quoted by the MVP in your class or even in solution books. Right? If they ask you to find your minimum variance portfolio, you know that from your formula of J, you have weight of J, sigma I J minus lambda R I minus mu equals to 0. If they ask you to find the minimum variance portfolio, you are going to let lambda equals to 0 and mu equals for all assets. And if this is the case, your equation is gonna look like this. You're gonna have C sigma 1 all the way to sigma 1 n, all the way to sigma n1, all the way to sigma n. So basically this is your covariance matrix. Your weight J1, like J is gonna be equals to 1. It's gonna be 1 all the way to n. It's gonna be equals to basically 1 up to 1. Like this whole row is gonna be equals to 1. Right. So this is how you find your minimum variance. So if they ask you to find any other efficient portfolio, then you are going to let mu equals to 1, lambda equals to 1, and then mu equals to 0. And then you'll find any other efficient portfolio. I think I can write it. Another efficient portfolio. So this is just what you have to know. You just have to know that you have to let it. You just have to let the thing be lambda equals to 0 and mu equals to 1 to find your minimum variance portfolio, and then 1 for lambda and then 0 for mu to find any other efficient portfolio. You just have to remember this line, and then you can solve it. So this one is going to be your covariance matrix. And normally they will give you your covariance matrix so that you can find your answer. Right, so we are gonna do a 2016 paper. I don't think I read. Okay, yeah, I think I did. I did
Sorry, I can't hear you.
I think my network is starting to act up. Yeah, I switched on the other mic. I think my network is acting up. I will have to log in again because I'm using two devices. So I think it's too heavy for the network. So anyway, I'm coming back. And I also taught a lot. I can see that my screen has frozen there.
Recording in progress.
This is how far I actually went since it froze. I wrote quite a lot of things since then. But then anyway, I hope we can all understand what's happening at this point. These returns here were negative, and the ones are negative, and the returns here you just write them as they are, and then you just write the ones over there, and then this one here is going to be your covariance matrix. So this is how you do the thing. So I'm not going to solve this thing because it's too long. I'm going to go to the next question so that we can learn a little bit. So in terms of two or two efficient funds, we normally call them mutual funds. If you have two efficient funds, then to find any other portfolio, you can write it as a combination of, again, you can write it as a combination of these two funds, right? So graphically, if you have a set of risky assets, right? So this is going to be your feasible set, right? So if this is going to be your feasible set, right? It's going to be your feasible set. Anyway, and then you have two securities, let's just say this and this, which are on the efficient frontier. Let's say that this is the efficient frontier. Né? If you have something like this, to find any other portfolio, so these two things over here, né? They are not just assets, but they are actually portfolios, right? They are portfolios of assets. These are portfolios. These portfolios, pot, right? You can say A, you can say B, or one or two. So when you have two portfolios which are on the efficient frontier, to find any other portfolio, let's just say maybe you're looking for this portfolio over here, né? To find any other efficient portfolio, né? You simply just have to add these two portfolios. So you can find portfolio as is a linear combination of the two portfolios. Is a linear combination of the two portfolios. I hope this makes sense. So if you have two portfolios, you can write it as a linear combination of the two. So to find portfolio S, or you can just say P, because we normally use P. Right, P. You can just say P. This is the weight for A, the returns for A, plus 1 minus weight of A, B, because they are two, you can write it this way. And then the returns for B, right? No idea what's happening now. Okay, yeah. So if this is the returns, I'll make this space over here. So you can just actually, yeah, you can just say 1 over 1 minus weight of A. You can just call it lambda, lambda, yeah, not lambda alpha. So you can just replace those two signs to answer your question. So to find how much asset you should buy for A, you just have to say this is going to be for your DZ portfolio minus the returns of B over the expected return of asset A minus returns of B. I hope this makes sense. So again, we're gonna do equation which which is gonna illustrate this thing. I mean, like this concept. Remember that you have two portfolios, A and B, and you're trying to make another portfolio. This is the portfolio you are trying to make. So in order to make it, you find the weight of asset A. Ultimately, the weight of asset B is just going to be 1 minus alpha, or 1 minus the weight of asset A, right? Either way you write it is fine. I hope if you have any question, please raise your hand. Anyway, this one is from 2019 paper. I can see the hands. Let me see. There are no questions. So anyway, this question say that there are three assets, X, Y, and Z, with expected rate of return 5, 9, and 10. Additionally, the covariance matrix is this. So find the minimum variance portfolio made up of asset A, of asset X, Y, and Z, where those things denote the proportion of each of the asset in the minimum variance portfolio. So they are actually asking you to find the minimum variance portfolio. I hope if I zoom in a little bit, you can all see. So they are basically asking you to find the minimum variance portfolio. I say that from this thing over here, from this, when you let this equals to 0 and mu equals to 1, you are actually finding the MVP, the minimum variance portfolio. Right, so this is how you find your minimum variance portfolio. Né? So this simply means that you're going to have your covariance 0, 1, and then you're going to equate it to what? You're going to equate it to 1, 1, 1, 1, 1, 1, right? I hope this makes sense, because if you let this thing equals to be equals, I think I didn't really explain it last time. You will have sum of this, by the way, J, weight of J, sigma I, J is going to be equals to 1, right? When you let mu equal 1, therefore, hence you have those ones that side. So you are going to reduce those. So you will have throw 2 is 1/3 1. This answer, you will have 3 minus 1 over 3, actually 1. We'll have 3, 1, 0, 1, 0. Eight, 3, 0, 1, 3, 1. Okay, now I think I will take time to solve this thing, but then anyway, I didn't want to take more time on like doing the calculation, but I think it's important that we do it anyway. So and then for this one, you will have root 3 minus okay, minus 3 over 8 root 2. So you basically have 0, 0. Root over 4. 3, 1, 0, 1, 0, 8 over 3, 1. I hope I didn't make any mistakes. The difference between you had to write a full matrix including lambda mu. This question where you only have to use first one and lambda equals to 0. So the difference here, the difference is that here, notice that they didn't tell you the desired portfolio. They didn't tell you the portfolio you are looking for. Instead, they just told you to find composition of return. They want you to find the minimum value where the return is going to be 17%. They literally stated 17%. Hence, you will have to find it, like you will have to include it in your calculation. And the only way to include it is if you write the whole equation. So now you are finding a solution based on a portfolio, like you have a desired portfolio. You are building a portfolio you want with the returns that you have specified. But then in this one, they just say find the minimum variance portfolio, right? They didn't tell you what those returns should be, but then it means that you just want to find the minimum variance portfolio. And if you let mu equals to, again lambda equals to 1. Show it graphically. You will answer for current portfolio 0 mu equals to 1. For any other portfolio, or anyway up then you will have to say mu equals to 1, lambda equals to 0. So you will find any other portfolio. So anyway, we only have 2 minutes to solve for this. So this means that wait, sorry. Wait 2 over 7. Wait for 2. over 7. And for 1, gonna be 2 over 7, right? So this is the weight. So notice one thing is that when you NVP, the weight almost all the time they are actually going to be they are actually not going to be they are going to be, and you will have to what, there's a word they use. The word they use is what, you will have to normalize it because they don't add up to 1, right? Remember that the weight should always add up to 1. If add weights, and this is not equals to, right? So in order to do, you will see that V1 is going to be to 2 over 7, 5, 7. Your answer is going to be what, 2 over 5, 1, which is going to be the same as 3. For weight 2 is 5. So anyway, the session is going to end. Please rejoin it. Please rejoin.